All right. Physiology students, so really quick, I've been noticing that not many people really use the video. So I'm contemplating, I don't know if I want to spend all the time doing the video when people don't really use it to their advantage. So what I do is if you're watching this video, if you email me by tonight before 12 a.m., 11:59 p.m., I will give you 10-point extra credit if you can write a paragraph, talk about the notes that we are doing today on endocrine system. So one more time, extra credit if you're watching this video. Try not to tell your friend, right? Because the more people we send, will be reduce the number of extra credits. So I want to test to see how many people actually watch this video. Okay, so extra credit if you send tonight, and tonight right now is Thursday. So Thursday night you have to send it to me. Right, so really quick, we are going to talk about endocrine system today. It's a quick system. We unfortunately we ran out of time, so we don't have time to really focus on it. But the endocrine system connect to the nervous system, right? They work with the nervous system. The nervous system is kind of like the master system. It's kind of like the one that send out electrical impulse, and they tell the endocrine system what to do. And both of them are to maintain here, both to maintain homeostasis. Remember homeostasis? Not too hot, not too cold. You want somewhere in between, homeostasis, right? So again, they are used for communication and they affect specific target, right? Just kind of like a nervous system controlling your, for example, your muscle. That is somatic, right? Somatic nervous system control. How about the one that you don't have conscious control, like your organs? That would be autonomic, right? So it's kind of like this, right? You have a neuron, right? Control another neuron, which in turn send the signal to the target cell. It's kind of like that. It's called neuroendocrine cell. So you have a neuron, and the job is to send to a neuroendocrine cell. It's like a connection between nervous system and endocrine, and they affect a target cell, like one of the organs on your body. Okay. All right, moving on. So all these, please look at it. These are all the endocrine glands. So glands like an organs, but we don't call them organ in endocrine system. We call endocrine glands. In your body, you have from top to bottom, right? Hypothalamus, right? That is part of your nervous system. Pituitary, pineal, thyroid, parathyroid, thymus, adrenal, kidney, pancreas, ovary, uterus, and tasty, right? So that would be the sex endocrine glands. So your sex organs are part of what we call endocrine glands, right? All right, endocrine gland and hormone, right? So there's the difference between endocrine gland and exocrine gland. We want to make sure you understand the difference. Exo, endo. So exo is that is duct. I mean, it has a tube. It has a tube. Thing are carried inside a tube, right? For example, your sweat and your salivary gland are considered exocrine. It's like tubes. Your sweat gland, they have tubes that carry sweat. Salivary gland, tube that carry your saliva. Endocrine gland, on the other hand, are not carried by tube. They are ductless, no tube. No tube. Okay, no. Okay. So how do they transfer their signal to a target cell? Well, they secrete hormone, right? So endocrine gland produce hormone, and these hormones are then travel to the bloodstream, right? To the bloodstream. And that's how it get carried on to different. It doesn't have its own tube like saliva or sweat. Endocrine gland transfer hormones into tubes. I mean into the bloodstream, and then from the bloodstream it then all travel around. So that's why it tends to be very located a lot around highly vascular area that has a lot of blood vessel, because they need to be able to pass on the hormone into the bloodstream. Okay. And again, another thing is exocrine glands, something that will take place right away, right? Where the signal will get there right away. Or for example, nervous system. Endocrine gland, on the other hand, will take time because things have to travel through the bloodstream. And we know that it has to go back to the heart, and then the heart pump to the rest of the body. And we'll talk about the circulatory system after endocrine system. So this is an endocrine gland, right? It secretes hormone, and this hormone are then moved to a target cell, right? Target organ. And that's how endocrine gland work. It carried through bloodstream. It doesn't have its own tube like exocrine gland. There are different type of hormone. You have peptide hormone, which are like protein. Okay, protein. You have steroid hormone. They are not protein. They are cholesterol. Okay, like testosterone. Male, female have it too, but small. Male hormone. Male sex hormone of a steroid. And you have biogenic amine. Is another term. It's not a protein. It just has an amino acid group. So those are the three different types of hormone that endocrine gland produce. Okay, I want to go review back to the negative feedback. Remember negative feedback? Negative feedback is when you go up and then it's too high, you bring it back to normal. Or you go down and then it bring back to normal. It doesn't have to always go up. It can go up, down, up. Everything go back to normal is what we call negative feedback or return to the norm, right? We'll call it to the norm, okay? For example, regulation of blood sugar level in your body, right? If it's too high, then you have endocrine system that control this to make sure it go back. You're too low, then you have endocrine glands that produce things that bring back the blood sugar into your blood. Right, this, right? So let's say you eat something, your blood sugar will increase. You have high blood sugar. Now this is your pancreas. It will secrete a hormone called insulin, right, in the liver to uptake these extra sugar, right, to convert these sugar into glucagon, and we'll talk about that. And that way your blood sugar is stable, right? So you don't have, and of course we know that people have diabetes, and that's because they have two types. That's because something is wrong with the insulin level, right? If you are type 1, you don't have enough insulin, so then you have to take insulin shot because your pancreas or endocrine gland do not produce enough insulin. If you have type 2, it's a little different. Your body just don't recognize insulin. So no matter how much insulin you have, your body doesn't detect insulin at all, right? So that's an example of negative feedback. And then you have positive feedback. Remember, positive feedback is more. So if I'm up here, I'm increased more than positive feedback. If I'm down here, I decrease more, that'll be positive feedback. For example, release of milk, right? For example, a mother who's breastfeeding a child, as the child feed more and more, the mother will produce more and more milk. So that's positive feedback. Instead of the mother produce less and less, right? It's more and more, right? Positive feedback. Or go more and more negative, right? It doesn't return back to normal. It doesn't return to normal. Norm? No norm. Okay. Okay, again, make sure you send the extra credit. Summarize what the note. Okay. And then email me by tonight, 11:59 p.m. Right? So we talk about breastfeeding. This is positive feedback. Okay. All right, we're gonna move on to different endocrine glands, right? Organs. Okay. Again, I'm gonna try to do this quick. You guys have to really read the note. So endocrine gland, the first thing we're gonna start out with the hypothalamus, which is the control center of the endocrine gland. It's part of the nervous system. Remember, endocrine gland work with the nervous system. Nervous system is kind of like the boss. It sends out signal, electrical impulse, right? Remember, from nervous system. And then hypothalamus is what will connect. And it will connect to, the first thing would be the pituitary glands. right here. This is the hypothalamus right here. Pituitary gland is right here. It's right underneath your cerebrum pretty much, right? These are two tight. You have the posterior, which is toward the back of my head, and anterior towards the front. So there's two endocrine glands that are controlled by the hypothalamus. And their job is to, the anterior pituitary gland, the front, usually has to do with regulatory hormone and releasing hormone or inhibitory hormone. Like it produces hormone to tell other endocrine gland to do more or to shut down, right? So it does both. Okay? And it's all controlled by hypothalamus, which is part of the nervous system. Okay. And then the hypothalamus, again, we're going to talk about, right? It controls the front, the anterior and the posterior pituitary gland. Posterior, the back, posterior gland, on the other hand, so this is the back, right? The back of my head right here. On the other hand, produce these two hormones, oxytocin and antidiuretic hormone. Oxytocin has to do with breastfeeding, milk, release more milk, and also giving birth as well. And antidiuretic hormone are more like for retention of water in your body. Okay, and again, this is posterior, and then anterior on the other hand are more for growth. So keep in mind, anterior more for growth, posterior more for oxytocin, antidiuretic. And also they are controlled by the adrenal medulla. We'll talk about that later. All right, so you have the, again, hypothalamus, control your pituitary gland, the front and the back. All right, and we're moving on. Again, the front pituitary gland control these things, thyroid stimulating hormone and another glands, right? Prolactin, which milk. And then, my bad, oxytocin is giving birth. Okay, my bad. Adrenal corticotrophic, right? Adrenal gland, which is release your adrenaline hormone to make you pump up sympathetic nervous system. And then it also control muscle growth hormone, muscle growth, fat growth, and also sex hormone, and so on. So anterior pituitary gland are very important. It control many of these growth. Think of growth. And posterior gland, on the other hand, oxytocin and antidiuretic hormone. It has to do with water retention. Okay. And moving on, thyroid gland. So thyroid gland is another gland that is controlled by your part of your your nervous system. Control it. It's like a gland on your throat here, right? You can feel it. It's right here, right underneath your Adam apple, right here, right? This is the gland that produces your thyroid stimulating hormone, thyroid hormone. And thyroid hormone has to do with growth, right? Has to do with metabolism, my bad. Has to do with metabolism. Thyroid hormone increase metabolic rate. Like, have you ever have friends that no matter what they do, they eat and eat and eat, but they're always skinny? And that's because they might produce too much thyroid hormone. Their body tend to be warmer because they constantly breaking down food for energy. And then you also have friends that they eat a little bit and they gain weight so much fast. And that's because their thyroid gland do not produce enough thyroid hormone. So that's why their body don't break the fat down fast enough. And they also control calcitonin, which has to do with calcium, right? It control to make sure that you have enough calcium in your bloodstream, so that way you have bone growth and so on. Okay. So review your note, and then the back, you also have what we call parathyroid gland. Parathyroid gland, on the other hand, has to do with calcitriol hormone. Again, has to do with keeping calcium, prevent the loss of calcium ion, right? It also help. So it's kind of like this, right? This is your parathyroid hormone. Let's say your calcium in your blood is low, and your body detect them, and it will stimulate your nervous system will stimulate your parathyroid hormone secrete into the bloodstream hormone. It travel to the heart, it go to the target area, and it tell different part of our organs to retain calcium. For example, the kidney, right? Resorb bone tissue, right? Small intestine to make sure suck back in the calcium instead of losing it. And so that way you have enough calcium for your bone. And then when you have enough, When you have too much, it sends another signal back. It will inhibit. This is what we call negative feedback, right? Inhibit. So it's kind of like a cycle. Too little, we turn it on. Too much, we turn it off. And then you have adrenal gland, right? Adrenal gland, just remember adrenal gland has to do with your adrenaline. And this is what control, this is a hormone called corticosteroid. It's a type of steroid hormone. It has to do with adrenaline, right? And your adrenal gland are on top of your kidneys, right here, top of your kidneys. Okay, so that's how I keep it simple. Just remember that adrenal glands right here, kidney. We usually have dissection. We get to see the adrenal gland on top of a pig kidney, but unfortunately we don't do dissection anymore, so we don't get a chance. And then your adrenal medulla are like the inner of the adrenal gland, and this is where it produces epinephrine, which is what we call adrenaline, right? Adrenaline is when you let's say some people, they often said that they get shot, they don't feel the pain right away because the adrenal gland produce adrenaline, epinephrine, make them pump up, right? Or same thing, norepinephrine, another type of epinephrine, right? Also keep us pump up, so we are fight or flight. So when your nervous system, especially autonomic nervous system and sympathetic nervous system, that make you feel fight or flight, that's because of the adrenal gland. They control your adrenal gland to produce these hormones to make you feel pump up. Adrenal gland. And then you have a pancreas. Again, we mentioned the pancreas earlier. Pancreas has to do with producing insulin and glucagon, right? Glucagon, insulin. So that's all you have to remember for now, right? You have different type of cells in your pancreas, and your pancreas are right here. It's like on top of your large intestine, right? And it's all in the middle of your body, right? And you have one pancreas, and its job is to control the blood sugar in your body. Like we said, when you have too much blood sugar, your pancreas will, when you have high blood sugar in your bloodstream, it promote insulin from pancreas will tell the kidney, the liver, to promote insulin, which in turn make more glucagon, make more glycogen, like to store the sugar, right, into fat. And when you don't have enough sugar, your pancreas will release glucagon. Glucagon in turn will stimulate your liver to break down glycogen, which is like sugar chains. So then you go bring back the blood sugar. So one more time, keep it simple. Pancreas has two very important hormones, control your blood sugar. If you don't have enough blood sugar, your pancreas will release insulin. It will stimulate your liver to release sugar. Okay. No, you have too much sugar. My bad. What am I doing? So you have too much sugar, your insulin will come out and tell your body to uptake the sugar and convert them into glycogen, sugar chain, to store them away. Fat, right? And then if you don't have enough blood sugar, your body will release glycogen, your pancreas, my bad, and it will tell your liver to break down sugar chain, glycogen, and release the blood sugar back into the bloodstream. So they are what we call negative feedback, right? They control each other. So read that note. And then you have a pineal gland, very, very, very small, right underneath your cerebrum, right? Pineal gland has to do with melatonin, right? Melatonin has to do with regulating your circadian rhythm to let you know when you need to sleep, right? Also, a role in sexual maturation. Okay, and that's why remember when back then we watched the Why Sex video. The Teen Dream video. You guys remember sophomore year, right? Because puberty tend to hit during the night, and that's because melatonin controls circadian rhythm. How do you know when to sleep at night and to wake up in the morning, right? Pineal body. And then you have a thymus in between your two lungs, and it has to do with your T lymphocyte, has to do with your immune system, right? Thymus produce these hormones that has to do with immunity, right? So read the note. Endocrine, kidney, heart, right? Endocrine, aging and endocrine system. Unfortunately, your endocrine system will only slow down as you age. So that's why people, as they age, their body break down fat slower, right? They gain weight faster, and also growth hormone, they don't grow anymore, and also sex hormone, testosterone, for example, estrogen, are produced less. So as people age, their endocrine system reduce, right? And that's it for the note. I want to keep it less than 20 minutes, but I'm 39. So make sure you write a summary for the e-interactive notebook check later on the end of May. So again, don't forget to send me the extra credit if you watch this video. I'm not going to announce it. All right, bye-bye.